Welcome for another physics lesson. We are going to study a question on energy, work, power, and machines. Therefore, we are told that in the figure 3 below shows the length of a spring when there is no load hanging on its length and when a force of 40 Newton is hanging on it. Therefore, we can see that when there is no force hanging on it, it has a length of 10, and when 4 kilograms, which is equal to 40 Newton, is hanging on it, we can see the length becomes 26 centimeters. Then we are told, determine the elastic potential energy stored in the string. We know that whatever we call elastic potential energy stored in springs is the kind of energy that is possessed by bodies which are elastic or which can be stretched through a given length. Therefore, if we can stretch or extend a certain object through a given length, then the body possesses what we are calling elastic potential energy. Therefore, the elastic potential energy of a body is given by the average of the force times the extension cost. And for this case, we are seeing without a body on it, it has a length of 10 centimeters. And when a body is hung on it, it goes to 26, which means extension here is equal to 26 minus the original length, which was 10, and we get 16 centimeters as the extension. These 16 centimeters can also be expressed as 0.16 meters to SI units. Therefore, with the extension now, and we have the force causing the extension, then we can give the elastic potential energy by taking half of the force, which is 40 newtons, times the extension cost, which is 0.16. And when we multiply 0.5 times 40, then we multiply with 0.16. This gives us 3.2 joules. Therefore, 3.2 joules is the energy stored in this spring. Alternatively, because we know according to Hooke's law, force is given by spring constant times extension, then we can say that the elastic potential energy can also be given by, instead of half F, we use constant K times extension, because force is KE. So KE is F, and we have again extension here. Therefore, we can say the formula becomes half constant times extension squared. So the extension becomes squared. Why? Because we have already force given by KE, and then we have again times extension. Therefore, the energy can be given by half KE squared. Therefore, now for this setup here, the constant can be given by taking a force of 40 divided by an extension of 0.16. Therefore, when we take 40 divided by 0.16, this gives us 250 newtons per meter. So the extension gives a spring constant of 250 newtons per meter. Therefore, we can now substitute the formula that energy will be given by half constant, which is 250, times extension 0.16 squared. Therefore, when we square 0.16, then we divide by 2, this will give us again 3.2 joules. So in either way, we are finding that the energy stored in this spring is 3.2 joules. Thank you for following. Subscribe to Shifting Grades and share the link.